Okay, so in probability, you're going to have to learn some counting techniques. And so in this section, we're going to talk about two, the addition and multiplication principles. Now, in order to find the probability of an event, you're going to have to be able to assign numerical values to the number of ways certain event can happen. So, like, you might want to find the probability of winning a lottery, or guessing the correct answer on a test, or selecting the ace from a deck of cards, rolling a particular sum on a pair of dice, or probability of having a boy or girl, probability that a light bulb or battery will last a certain amount of time, probability that you will wait in line for a certain amount of time, probability that an electronic device will have a defect within the first year, probability that a person contracts a disease, or probability that a person will file an insurance claim. That's for insurance companies. And so these are just a few samples. Now, the way you determine the probability of an event, to put it simply, you basically take the number of ways your event can occur and divide by the number of total possibilities. Now that assumes each event is equally likely to occur. If they're not equally likely to occur, then we have other ways we can approach it. So basically, let's look at an example of one where we can assume the equally likely assumption. Suppose you toss two coins, and what if you wanted to know the probability that both coins are heads? Well, you could write a list of outcomes. Now there's actually only 4 possible outcomes here. Now I've listed 4 possible outcomes here. Both coins could be heads. The first coin could be heads, the second tail. The first coin could be tail, the second one head, or they could both be tails. Well, there's only one way to get the desired result, and that's this one, head, head. So there's one way out of 4. So if we assume each of those 4 outputs are equally likely, then there's one way out of 4. Now, in other examples, it might not be so easy to count. What if you bought a lotto ticket? You want to know the probability that your numbers are selected. Could you write out all possible scenarios? I doubt you'd want to try. Or what if you're dealt a 5-card hand and you want to know your chances of getting a full house, which is 3 of one kind and 2 of another? Would you want to write down every 5-card hand that results in a full house so you can count them? Again, I doubt you would. So what we need to do is we need to learn some techniques to count. So you can read this paragraph on counting techniques right here. Make sure you read it and then move on, but I don't feel like I want to read that to you. So let me just talk to you about the counting techniques we're going to talk about. In this section, we're going to talk about the addition principle and the multiplication principle. In the next section, we'll talk about permutations and combinations. So we already talked a little bit about set notation, so this is sort of a refresher. Remember, U is the universal set, and so if we selected a card from a standard deck, U would be the set of all 52 cards. Now, but if our experiment was selecting a 3-card hand, then U would be the set containing all possible 3-card hands. Now that's a huge difference, because in the first case you would only have 52 elements in U, but in the second case you would actually have over 22,000 3-card hands. So we won't get into that yet, but I know that's the answer. Okay, now remember the union of two sets. Okay, let's talk about the universal set. Let's say the universal set consists of all these shapes. Okay, let's say A is this set, circle, triangle, square, hexagon. B is this set, octagon, square, diamond, triangle, and C is this set. Well, then A union B would be everything in A plus everything in B. So it would be circle, triangle, square, hexagon, then octagon. We already counted square. Okay, so it would be octagon, square. Let's see, we already counted square. So diamond, and we already counted triangle. So that would be A union B. A union C would be everything in A, circle, triangle, square, hexagon, and then pentagon, heart, diamond. So we'd have to throw those in. So that would be the union. And now the intersection, if I wanted the intersection, A intersect B, well, in A and B, the only thing that's in both of them are the square and the triangle. So the square and triangle. And then in B intersects C, the only thing that's in there that's in both of them, that's in both those sets, is the diamond. So B intersects C would be the diamond. And then if I use the same sets and I wanted the complement, so if I wanted the complement of set A, it would be everything from the universal set that's not in set A. So I would actually just remove, I would just go up here and remove the circle, the triangle, the square, and the hexagon, and then what's left would be A prime: pentagon, heptagon, octagon, diamond, heart, and star. Okay, and you can do B prime and C prime the same way. Okay, now remember, the capital letter A defines a set, but if you see this notation with a little n in front of it, that notation tells you how many elements are in the set. So capital A had circle, triangle, square, hexagon, but the number of elements in A is 4. So just remember that notation, and you can read the other two examples there. Okay, A intersects C. Let's see, if you go back up here and look at A intersects C, I think I have it where there's no intersection, maybe not. Okay, well, looks like I have, wait, that's B prime, that's A prime and C prime. How about A intersects C? Okay, so A intersects C, let's see, is there an intersection in those two sets? No. So I could say A intersects C is the empty set, and when a set is the empty set, then the number of elements in it equals 0. So understand that this notation and 0 are related, but they're different meanings. And then, of course, lowercase letters can represent the elements of a set, and so on. Now, the addition principle gives us a way to find the number of elements that are in the union of two sets. So the number of elements that are in the union of two sets are equal to the number of elements in the first set plus the number of elements in the second set minus the number of elements in the intersection. So go back to sets A and B from above, the number in A union B. All right, let's go back and look at sets A. So in set A, I had 4 elements. In set B, I have 4 elements. And then in the intersection of A and B, let's see how many I have. Remember, I had the square and the triangle. So there's 2 elements in the intersection. So in the union, I would have 4 elements plus 4 elements minus 2 elements to get 6. Now the reason we have to subtract off that 2 is because if you simply just add 4 and 4 up here, if you simply just add the 4 here and the 4 here, then you're actually counting the square and the triangle twice. So to correct that, we subtract the number in the intersection, and that corrects it. Now, if there's no intersection, then you don't have to correct it. So A union C, if you go back and look at A and C up here, well, A had the circle, triangle, square, hexagon, and C had the pentagon, heart, and diamond, and there's no intersection between A and C, so there's no chance of you duplicating. So if there's no intersection, then you can just simply add the number in A plus the number in C and add them together. So in other sets, it might be too difficult to check the answers, so we need this principle. Okay, here's a simple example. Suppose we let the universal set represent the 52 cards in a standard deck. Let's say A is the set of all red cards. So that would be all hearts and diamonds. Now I'm not going to list them all, but there's kind of what it would be. Now there's 13 hearts and there's 13 diamonds, so that'd be 26 cards in set A. Let's say B is the set of all face cards. Now face cards are jack, queens, and kings. So there's a jack, queen, and king of hearts, jack, queen, and king of diamonds, jack, queen, and king of spades, and jack, queen, and king of clubs. So there's a total of 12 elements in that set. And then last, let's let C represent the set of all twos. Well, there's a 2 of hearts, 2 of diamonds, 2 of spades, and 2 of clubs. So there's actually 4 in that set. Okay, now if I wanted to find the number in A intersect B, okay, that's pretty easy. The number in A intersect B would be all those cards that are red cards or face cards. So the jack of hearts, queen of hearts, and king of hearts are face cards and they're red cards. And so are the jack, queen, and king of diamonds. So the number in the intersection is 6. Well now, suppose I want to know how many cards are either red cards or face cards. Now, or is generally the key word for union, and is generally a key word for intersection. So I want to know how many are red cards or face cards. Well, in that case, take all the red cards, which is 26, then add to that all the face cards, and then subtract off the cards that are in both sets, or the intersection. So we have 26 plus 12, and then minus the 6 from up here gives me 32. And then if I want to know the number that's in B intersects C, face cards, how many cards are face cards and 2s? Well, that's an empty set, so there's 0 in that set. So if I want to know the number in the union, all I have to do is add the number that's in set B plus the number in set C. So there's 12 in set B, 4 in set C, so I get 16 for the answer. Now another way to look at this is to fill out a Venn diagram. Okay, so here's the Venn diagram. Notice I have 52 out here. That represents the total that are in this rectangle. And then remember, set A had 26, set B had 12, and we knew that there's 6, the Jack, Queen, and King of Hearts, Jack, Queen, and King of Diamonds, so there's 6 in the intersection. So how many are red and not face cards? We'll take 6 away from 26, and that'll give you 20. There's 20 there. And then how many are not red cards but are face cards? Well, out of the 12 face cards, take the 6 that are red away, and that leaves you 6 that are not red. Well, now if you add these together, you actually get the union, because these are 3 non-intersecting sets. So if you add them together, you don't have to worry about overlap. So there's 32 in the union. Well, that means there's 32 cards that are either red or face cards. So if you want to know how many cards are not red and not face cards, then that would be 52 minus 32, which equals 20. And so by filling all that out, you can answer pretty much any question that's asked about those cards. And later we might ask questions like, if I select a card, what's the probability that the card's neither red nor face cards? Well, then your answer would simply be 20 out of 52. Okay, here's another one. We have 35 students. We have 19 that are married, 20 are blonde, and 7 are both married and blonde. So I'm just going to go straight to the Venn diagram. 35 total. A is my married student, so I have 19 that are married. B is my blonde students, so I have 20 that are blonde. And so this circle represents the married, this circle represents the blonde. I have 7 that are both, so take 7 away from 19, and I got 12 that are married and not blonde. Then take 7 away from 20, and I have 13 that are not married and are blonde. And then if you add these 3 together, you get 32. So take 32 away from 35, that means that you have 3 out here that are neither. And then you can use that information to answer the questions. So I'll let you freeze the video if you need to, and then read the questions and the answers and see if they make sense, and then you can move on when you're done. Number 2 is just like number 1. So again, fill out the Venn diagram and then go back and answer the questions. And again, pause the video if you need to, and then restart it after you've looked at the questions and answered them. Okay, take a look at number 3, and notice here this time I gave you the number in the universal set and I gave you the number in the union this time. Well, if you want the number in the intersection, that's the key to answering this question. You can still use this formula because we know that there's 105 in the union, there's 50 in A, there's 75 in B, and then if you want the number in the intersection, you can figure it out by solving this equation. And then you can answer the rest of the questions. Okay, here's a couple of practice problems for you to practice on, and the answers are given. So what you can do here is you can work these problems, freeze the video and work these problems, and then after you do that, check your answers. And then if you need to, go back and work them again. And then you're pretty much done with the video. So you can see the bottom. I'll kind of cut that off. It's 16 is outside the 3 circles. But basically those are the problems. So read them, work them, and then we're pretty much done with this section on the addition principle. And I'm going to finish this video in the next section when I talk about the multiplication principle.